we have here is trigonometry questions, okay? And in trigonometry questions, you're going to have three sides. You're going to have the hypotenuse, which is the longest side, and you have two smaller sides. Now, the two smaller sides are called the opposite and adjacent, and it depends on which one you're talking about. So if I'm talking about angle A looks directly at the 4, so 4 is opposite of A. That makes 3 is the adjacent of A. Likewise, if I'm talking about angle B would be looking straight at the number 3, so number 3 is opposite B. That means the number 4 would be adjacent to B. So we'll play this video here, okay? What we're going to do is just going to go through this because I made it previously, but there was no sound on it. Okay, so there's three sides. This is angle A. We're just going to concentrate on angle A first. And with angle A, we have our three sides. And what we're going to do is we're going to label all three sides sooner or later. Let's see if I do that. Hypotenuse is the longest side, which is 5. 4 is the opposite because it looks to angle A, and 3 is the adjacent. We next write out this rhyme. It's called Silo Harry, chase a horse through our attic. There's three trigonometric functions. They're called sine, cos, and tan. Sine is opposite divided by hypotenuse. Okay. Cos is adjacent divided by the hypotenuse. And finally, tan is opposite divided by the adjacent. Okay, so that's all good. Now, what we're going to do next here, guys, is we're going to start trying to answer some of these questions on exercise 16.1. You can see that we're trying to figure out what sine A, cos A, and tan A are in each of the three questions for angle A. Okay, so here's what we're going to do. You see sine A down here. See the way it has 4 over 5? Okay, so we're going to find out what sine A, cos A, and tan A are. And you see sine A is already done for us, okay? So let's move on a bit. So sine A is opposite over hypotenuse. That's why we got 4 over 5 for sine A. Cos A is adjacent over hypotenuse. That's why we're getting 3 over 5 for cos A. Tan A is opposite over adjacent, which is 4 over 3. As you can see, the opposite is 4 and the adjacent is 3. Next thing we're going to do is move on to question 2 and once again look at angle A. The hypotenuse is 17 in this triangle. Angle A looks at the 15, so therefore 15 must be the opposite. Eventually when I write it. Okay, and this leaves that 8 is the adjacent. Now we're going to answer part 2. What is sine A in the second triangle? Well, in the second triangle, it's opposite over hypotenuse, so that must mean it's 15 over 17. Okay, cos A in the second triangle is adjacent divided by hypotenuse, which means it's 8 over 17. Okay, and then finally, we're now on to the third triangle. Once again, we're looking for angle A. Okay, so what did I do there? Oh yeah, this is a 90-degree angle. This specifies that the hypotenuse is 17 because it's opposite the 90-degree angle. The angle A looks at 15, so therefore 15 is the opposite, and 8 therefore must be still the adjacent. Okay, so then we do opposite divided by hypotenuse. We're still going to get the opposites 15, and the hypotenuse is 17. So it should be 15 divided by 17 for this one. Okay, we'll just skip through a little bit. So 15 over 17. Next one we're going to do is adjacent over hypotenuse for cos, because this is where this part goes in here, and that's 8 over 17. Okay, now we're on to triangle 3, hopefully. We've done this right, there's triangle 3. And what we do with triangle 3 is we blank out the B and we concentrate on the A. The 2 is the hypotenuse because it's the longest side in the triangle. The root 3 is the opposite because that's what the angle A is looking at, and therefore 1 is the adjacent. So what we're going to get here, guys, is the first thing we need to do is we need to find out what sine is. Sine is opposite over hypotenuse, which is root 3 over 2. And therefore adjacent, and then tan will be opposite divided by adjacent because it's O over A, which we can see. So that would be root 3 over 1, which is simply root 3. Okay. Now we're going to move on to angle B's. Okay, we're looking at angle B this time. You see, angle B is looking at the 3, so 3 is opposite B, hypotenuse is still 5, and the adjacent is now 4. So what can we do regarding sine B? Well, sine B, we're going to label off all three of them here now. So see in the second triangle, angle B looks at the 8. 8 is the opposite, 17 is the hypotenuse, and 15 must be the adjacent. In the third triangle, angle B is looking at the 1. This makes 1 opposite. Hypotenuse is the longest length, and the root 3 here is the adjacent. Next, we're going to have to fill out our table for sine B, cos B, and tan B. Well, what we can see here is that in triangle 2, the opposite over hypotenuse is 8 over 17. In triangle 3, we can see that the opposite is 1 and the hypotenuse is 2, so that means this is 1 over 2. Next here we're going on to cos B, and what we have here is cos B is 4 over 5 in angle 1 because it's adjacent over the hypotenuse. Okay, and then in triangle 3, the adjacent over the hypotenuse is root 3 over 2. And finally, in the first triangle, tan is opposite over adjacent, which is 3 over 4. In the second triangle, the opposite is 5 and the adjacent is 15, so it should be 8 over 15. And there we go. There is how you use that table for sine, cos, and tan. Next thing we're going to do is evaluate a few of these using the calculator. So you just throw them into the calculator. You can get 5 squared plus 12 squared is 25 plus 144 equals 169. You can throw 4 squared minus 3 squared is 9. Okay, so these are just some general questions. In question 10, you can see it's 2 squared minus root 3 squared. Root 3 squared is 3. And then root 13 squared is 13. 13 take away 4 should be 9. Okay, so we got a couple of those questions done. Now in this question here, use Pythagoras Theorem to find x, the length of the missing side, and in surd form where necessary, express sine theta, cos theta, and tan theta in simple fractions or as surd fractions, each of the following. Okay, so what question are we going to take first? Fast forward a little bit. We're going to take a question, which we're going to do our own question here first. So I'm making up a right angle triangle. In fact, I'm going to make up 2 right angle triangles by the looks of it. And this one's 11, 8, and 6. Now the problem here is we need to use Pythagoras Theorem to check out which triangles are legitimate right angle triangles. Okay, so next one we have 9, 8, and 6. Okay, now all of these can't be a right angle triangle. In right angle triangles, the hypotenuse squared, the longest side squared, has to equal the other 2 sides squared and added together. So in the first triangle, 10 squared is the longest. It has to equal 8 squared plus 6 squared. Check your calculator out and you get 100 equals 100. So you're going to get 64 plus 36, which means 100 equals 100. This means the triangle with 10, 8, and 6 is in fact a right angled triangle. The next one we have is 11, 8, and 6. Okay, and we're going to see what happens this time. Well, in this case, which is triangle B, the 11 is longer than the 10, and it causes it not to be 90 degrees anymore. It will cause it to be bigger than 90 degrees. See the way we're making that 11 slightly bigger? So you're going to get 11 squared equals a squared plus 6 squared. We know this is not going to be true because 11 squared is 121, and a squared plus 6 squared is 100. Because the 11 squared is too big, it doesn't obey Pythagoras' theorem because it doesn't balance. This means that this triangle in the middle with 11 as its longest length, 8 and 6, is not a right angled triangle. Okay, so that means it's not a right angled triangle. Okay, next thing we're going to do is it's going to be an obtuse angle because the hypotenuse squared is bigger than the other 2 sides squared and added together. The next scenario we're going to use is 9, 8, and 6. In this case, the 9 is smaller than the 10 was. So in a way, we can shorten that 9 down a little bit, okay, and bring it towards it. And this makes this angle here smaller than 90 degrees, which will make it an acute angle. Okay, so then when we do Pythagoras' theorem one more time, we're going to get 9 squared equals a squared plus 6 squared. 81 equals, does not equal 100. So basically 81 is less than 100. This makes this an acute angle with 2 C's, not just 1. Okay, spelling obviously not my forte. So In each of the following questions, use Pythagoras Theorem to investigate if the angle marked theta in each of the following triangles is equal to 90 degrees, less than 90 degrees, or greater than 90 degrees. So if we go back to the original question there, what you can see is that you have to use Pythagoras Theorem for all 4 questions. If they equal, it's right angled. If the hypotenuse squared is bigger, it's obtuse. And if the hypotenuse squared is smaller, it's acute. Give it a go. So in the question 1, we're going to use 6 squared equals 4 squared plus 5 squared. 6 squared is 36, 5 squared is 25, and 4 squared is 16. And what we can see there is that 36 is less than 25 plus 16, which is 41. This means that this must be an acute angle because it must be smaller than 90 degrees. Okay, moving on to the next one, question 4. We're going to do 11 squared equals 10 squared plus root 13 squared. So we have 11 squared equals 10 squared plus root 13 squared. And what we're going to get here is 121 equals 100 plus 13. 121 is bigger than 113. Because the hypotenuse squared is bigger than the other squares on the other 2 sides added together, this must mean it's obtuse. Okay, well, that's a good job. Now we're back to question 4, where we're going to use Pythagoras Theorem, and then we're going to find out sine, cos, and tan of 1 or 2 of the following triangles. Okay, so let's take the first triangle. We have the longest side, which is 13 squared. It has to be equal to 12 squared plus x squared using Pythagoras Theorem. 13 squared is 169, 12 squared is 144 plus your x squared. We got to move that 144 from the right hand side to the left hand side, or something similar. Take it away from the 169. So we're going to get 169, take away 144, which should be 25. Okay, so x squared equals 25. X therefore must be the square root of 25, which is 5. That makes the length of this one, the x value, 5. Okie dokie. Next thing we're going to try and do is we're probably trying to get sine, cos, and tan of this triangle here. So cat toa. Okay. And what we're going to say is that the theta looks at the 12. This makes the 12 the opposite. The hypotenuse is the 13, the longest side, and 5 is the adjacent. So now we're going to use sine theta must be opposite over hypotenuse, which is going to be our 12 over our 13. Okay, so we need the opposite side over the adjacent side. So opposite over hypotenuse, my fault. So it's 12 over 13. Next thing we're looking for is cos theta, which is going to be adjacent over hypotenuse, which is going to be 5 over 13. And then finally, we're going to need tan theta, which is opposite over adjacent, which should be our 12 over our 5. Okay, that's a good bit of that work done already. Okay, next thing we have is part 6. Okay, so we're going to do part 6 this time, where x is the longest side in the triangle. So we're going to say x squared, which is the hypotenuse squared using Pythagoras Theorem, equals to 2 smaller sides squared and added together, which is 2 squared and 3 squared. X squared equals 2 squared, which is 4, 3 squared, which is 9. X squared equals 4 plus 9, which is 13. X must equal the square root of 13. Now we know what the hypotenuse of this triangle is. Okay, so we're going to use this knowledge to try and find the answers to what sine theta, cos theta, and tan theta are for question 6. Okay, so there's root 13, that's the thing, right? So what we're going to do next is we're going to say cos theta is adjacent over hypotenuse, which is 2 over root 13. Sine theta is going to be 3 over root 13 because it's what's opposite over hypotenuse. Okay, and then finally tan theta is going to be opposite over adjacent, which is 3 over 2. Okay, that's that done. Okay, next thing we're going to do is move on to question 6. Given that tan theta is 3 over 6, Label angle Q on the diagram. Well, if you're talking about tan, you're talking about C has to be the opposite over adjacent. So no, that's not right there. We'll fast forward this for a second. I think I got this the wrong way around. So C is the opposite and D is the adjacent, okay? So C over D. Okay, so ignore that last one, lads. That one didn't make any sense whatsoever. Let's go to question 10. 29 sine theta equals 21. What we're going to do here is we're going to move the 29 underneath the 21. So we're going to get sine theta equals 21 over 29. Okay. Then what we're going to do next is we're going to draw a right angle triangle and try and use Pythagoras Theorem to figure out what the missing side is. So because it's sine, we know the opposite is 21 and we know the hypotenuse is 29. Okay, so it's going to be 21 over 29. We're going to use SOHCAHTOA to figure out what tan is. Okay, so first of all, hypotenuse is 29, opposite is 21. So it's 21 and 29 there. And that's the angle we're talking about, angle theta. We're going to label the adjacent side x, and then we're going to do Pythagoras Theorem to figure out what the x value is, where 29 squared equals 21 squared plus x squared. 29 squared is 841. 21 squared is 441, and then plus x squared there. Move to 441 and take it away from the 841 to get 400. Square root that, and you're going to find out that the x value equals 20. So the x value equals 20 right here. Okay. Next thing you're going to realize, guys, is that it's we have to find out what tan is. Tan is opposite divided by adjacent. So opposite to theta is the 21 and adjacent to the theta is the 20. So we're going to find out that tan theta is simply 21, which is the opposite, and then 20, which is the adjacent. So it's going to be 21 over 20. Okay, guys, that's all we have to report on this for today, I'm afraid. So